a 425 cubic inch V8, 385 horsepower, sent through the front wheels. In 1966. Stick around because by the end of this video you're going to understand a piece of engineering so strange that Detroit basically forgot it happened, and I want to know in the comments if you'd have bought one. Let's get into it. Picture the American car industry in 1966. Every manufacturer is obsessed with one thing and one thing only: horsepower going to the rear wheels. Pontiac and Chevy are in an open cubic inch war. Ford just dropped a big block into the Mustang. Drag strips are packed every weekend. Burnouts, quarter-mile times, rear axle ratios, that's the entire conversation. If you'd walked into a GM boardroom in 1965 and said, "What if we built a giant luxury coupe where the front wheels do all the work?" you'd have been laughed out of Detroit. Except Oldsmobile actually did it. And they didn't do it quietly, either. They built one of the most radical drivetrains in the history of the American automobile, wrapped it in a gorgeous personal luxury coupe, and rolled it into showrooms right in the middle of the muscle car era. This is the story of the 1966 Oldsmobile Toronado, and specifically, the story of the bizarre chain-driven, sideways transmission, big block front-wheel drive system that powered it. Stay with me, because this one gets genuinely strange. To understand why the Toronado was such a shock, you need to understand just how completely front-wheel drive had died in America. The last front-wheel drive car sold on American soil before the Toronado was the Cord 812. That car went out of production in August of 1937. Do the math, that's 29 years. Nearly 3 decades where every single American production car used the same basic layout. Engine up front, driveshaft running down the middle of the car, power going to the rear wheels. No exceptions. No experiments. Nothing. The Cord itself deserves some credit here, because it wasn't a bad idea, it was ahead of its time. Designed by Gordon Bierig, the Cord 812 had hidden headlights, a coffin nose grille, and genuine front-wheel drive at a time when almost nobody in America was even trying that layout. It was stunning to look at. But it was also unreliable, it was expensive to build, and the whole company was in financial trouble. It died after just 2,320 units. And the lesson the American industry took from that failure wasn't, "Let's refine this and try again." It was, "Front-wheel drive doesn't work here, full stop." For nearly 30 years, the entire domestic industry acted like the concept simply didn't exist. Now, that wasn't true everywhere. European manufacturers kept experimenting the whole time. Citroën built the traction Avant before the war and never looked back. They'd stay committed to front-wheel drive for decades. The British Mini launched in 1959 and showed the entire world how compact, efficient, and genuinely fun front-wheel drive could be when it was engineered properly. But here's the thing, none of those cars were fighting the problem Oldsmobile was about to take on. The Mini had a tiny engine making a fraction of the power. Nobody, anywhere in the world, had put a genuine American V8 through the front wheels of a full-size luxury car. Detroit was making money hand over fist with conventional rear-drive layouts, gas was cheap, horsepower was king, and nobody had any financial incentive to change anything. Until someone at General Motors decided to try anyway. Here's something most people don't realize about the Toronado. The drivetrain concept behind it didn't start in 1966. It didn't even start in 1958. It starts in 1954, in the backrooms of GM's engineering staff, with a concept that got the internal name the Unitized Power Package, the UPP. The idea, on paper, was elegant. Take a V8 engine and a transmission and package them together as a single, tightly integrated unit, with the engine driving the front wheels, and do it efficiently enough that the whole assembly could fit into roughly the same physical space a conventional front-engine, rear-drive setup would occupy. In theory, you get all the packaging benefits of front-wheel drive: no driveshaft tunnel eating into your interior, a flatter floor, better traction in bad weather, without sacrificing the big American V8 that customers actually wanted. In 1955, GM actually showed this idea to the public. At their traveling Motorama show, which was basically GM's rolling circus of concept cars that toured the country building hype, they displayed a Roadster and a 4-door hardtop called the LaSalle 2. Both were said to feature front-wheel drive built around the UPP concept. Sounds impressive, right? Here's the catch. The show cars didn't actually run. The drivetrains were mock-ups. Beautiful, convincing mock-ups, but mock-ups. The concept existed on paper and in styrofoam and sheet metal, but not yet in working, functioning metal that could actually turn wheels. GM's engineers kept developing it anyway, mostly out of the spotlight. By 1958, Oldsmobile's own engineering team got hold of the UPP concept and effectively adopted it as their mission. The man who shepherded the project was an engineer named John Belts, and if that name means anything to you as a car enthusiast, it's because Belts is the same man who had originated the legendary Oldsmobile 442 performance package. This is worth sitting with for a second. The guy responsible for one of Oldsmobile's most aggressive muscle car programs is the same guy who bet his career on front-wheel drive being the future. That's not a contradiction, by the way. It tells you something about how seriously Belts took engineering problems generally, whether the goal was raw power or completely reinventing how power got to the pavement. Early prototypes used a V6 engine, which made sense as a starting point. Smaller, lighter, easier to package while the team worked out the fundamental architecture. But by 1961, the team made a pivotal decision. They switched their focus to large V8s paired with automatic transmissions, because that's what Oldsmobile's actual luxury customers demanded. This is a crucial point in the whole story. A front driver that felt underpowered, that couldn't compete on paper with a big rear-drive luxury coupe, would have been dead on arrival in the marketplace no matter how clever the engineering was. Oldsmobile wasn't building a science experiment. They were building a product real customers had to want to buy. So the V6 got shelved, and the team committed to solving front-wheel drive at true American V8 scale. By January of 1963, the basic layout was locked in. 7 years after the UPP concept first got sketched out, and 9 years before the finished car would actually reach a showroom in the fall of 1965 for the 1966 model year, Oldsmobile's engineers finally had an architecture they believed could work. And what they designed was genuinely unlike anything else on the road, anywhere in the world. Let's talk about why front-wheel drive is actually hard, because this is the heart of the whole story. The single biggest engineering challenge with front-wheel drive is getting power from the engine all the way to the steering wheels. And I want you to actually think about what that means mechanically. Those front wheels don't just spin around one fixed axis like a rear wheel does. They also have to pivot left and right when the driver turns the steering wheel. So somehow, you need a mechanical connection that can transmit huge amounts of torque to a wheel that is simultaneously being asked to change its angle relative to the car, sometimes by 30 or more degrees, while still driving down the road. The Cord had solved a version of this problem back in the 1930s with a relatively simple universal joint setup. But, and this is important, the Cord never had to deal with anything close to 475 lb-ft of torque. Its engine was a fraction of the size and power of what Oldsmobile was working with in the 1960s. The forces involved in the Toronado project were in a completely different league. You can't just scale up a 1930s solution and expect it to survive. So there was the steering problem. But there was also a packaging problem, and this one turned out to be just as difficult to solve. A standard turbo-hydramatic transmission, the kind GM was already building and using across its lineup, is simply too long to mount pointing straight forward from the back of a V8 engine. If you tried to do that, positioning the transmission behind the engine the normal way and then routing power forward to a front differential, you would literally run out of hood length before the differential ever got anywhere near the front wheels. The car would need an absurdly long front end just to physically fit the parts, and that would wreck the whole point of a sleek personal luxury coupe. So Oldsmobile's engineers did something clever and slightly insane. They flipped the transmission. Here's how it worked. The torque converter, the fluid coupling that connects the engine to the transmission, stayed exactly where you'd expect it, right behind the engine. But the actual planetary gear sets, the part of the transmission that does the gear shifting work, got physically repositioned to sit alongside the engine instead of behind it, running in the opposite direction to the engine's rotation. The engine and the transmission now sat parallel to each other, side by side, rather than end to end. This dramatically shortened the overall length of the drivetrain, which solved the packaging problem. But it created a brand new problem. If the torque converter is behind the engine, and the transmission's actual gear processing unit is now sitting alongside the engine instead of behind the torque converter, then the torque converter's output shaft and the transmission's input shaft are no longer lined up with each other. They're now sitting parallel to each other, offset, with a physical gap between them. So how do you get power from one to the other? The solution Oldsmobile's engineers landed on was a chain. Not a belt, not a secondary shaft with more universal joints, a chain, running inside the engine bay, doing the job of connecting a torque converter to a sideways transmission input shaft, and handling every single one of those 475 lb-ft of torque in the process. Let's get specific, because the numbers here are genuinely wild for a mass-production American car in 1966. The chain was a high-vo roller chain, developed specifically for this application in partnership with BorgWarner's Morse Chain Division, a company that specialized in industrial power transmission chains, not automotive parts. This wasn't an off-the-shelf component. It was 2 inches wide. It was 46.5 inches long. And it was made up of 2,294 individual pieces, all precisely machined and assembled to survive being twisted by a big block V8 for the life of the car. Getting that chain to run quietly and reliably took serious engineering effort. Oldsmobile's engineers hand-selected 4 different sprocket diameters per unit specifically to optimize chain slack, because too much slack means noise, vibration, and premature wear, and too little slack means excessive friction and heat. Then, once the mechanical tuning was dialed in, they wrapped the entire chain housing in molded fiberglass reinforced rubber specifically to kill the noise. Remember, this is a luxury car. The target customer was never supposed to know that chain was even there. They were supposed to experience a smooth, silent, powerful luxury coupe, not an industrial machine shop under the hood. From the transmission, power then ran through a set of bevel gears into a narrow planetary differential, and out through equal-length half-shafts to the front wheels. That word equal is doing a lot of work in that sentence, and it's worth explaining why. Equal-length shafts were completely non-negotiable for this design. If one half-shaft were longer than the other, which is actually common in a lot of front-wheel drive designs, even modern ones, due to packaging constraints, you get uneven torque delivery to the 2 front wheels under hard acceleration. That unevenness is exactly what causes torque steer, that unpleasant tugging sensation in the steering wheel when you plant your foot and the car tries to pull itself toward one side. With 385 horsepower and 475 lb-ft on tap, uncontrolled torque steer would have made the Toronado genuinely unpleasant, maybe even unsafe, to drive hard. So the engineers built the entire front differential and half-shaft assembly around the principle that both sides had to be identical in length. There's more. The entire drivetrain assembly was offset 1.8 inches to the right of the car's centerline, specifically to clear the steering gear, which needed its own dedicated space in an already extremely crowded engine bay. And the intake manifold itself was completely redesigned with a flatter profile specifically to drop the overall engine height by 2.6 inches, because without that reduction, the whole assembly simply would not have fit under the low, sleek hood that the design team wanted for the finished car. Every single one of these numbers represents a custom-engineered solution to a problem that had never been solved at this scale, by anyone, anywhere. This wasn't an adaptation of an existing system. It was built from scratch. Now, all of that engineering would have meant nothing if the car wrapped around it didn't sell. So let's talk about how the Toronado actually looked, because the styling story is just as interesting as the mechanical one. It started with a sketch by Oldsmobile designer David North back in 1962, years before the drivetrain was even finalized. North's sketch was a low, aggressive coupe that he personally nicknamed his Flame Red car. When Oldsmobile's management gave the green light to build a personal luxury coupe for the 1966 model year, North's sketch was the one they chose to bring to production, more or less as originally conceived. The finished car had hidden headlights, tucked away behind rotating covers for a completely clean nose when they weren't in use. It had a broad horizontal grille that deliberately echoed the old Cord, a subtle nod, whether intentional marketing or design team in-joke, to the last American car brave enough to try this layout. It had exaggerated wheel arches that flared out from the body, clean body surfaces with a real absence of excessive chrome trim compared to typical mid-60s American design language, and a pillarless hardtop roofline that gave it a sleek, uninterrupted silhouette with the windows down. At 211 inches long, it looked like absolutely nothing else on the road. It was massive, but it was also low and wide in a way that made it look more like a European Grand Tourer than a typical American land yacht. And here's where the drivetrain engineering directly paid off inside the cabin, because there was no driveshaft running down the middle of the car. Remember, all the power delivery was happening up front through that chain and differential. The interior floor could be completely flat. That meant 6 adults could sit in the car, 3 across in the front bench and 3 across in the back, with legroom that genuinely rivaled sedans far larger than the Tornado's own footprint. The instrument cluster featured rocker switches and a rolling drum speedometer that looked like it had been pulled straight out of a fighter jet cockpit. The whole cabin felt deliberately futuristic, because that's exactly what Oldsmobile was going for. This was a car built to feel like the future had arrived early. Now let's talk honestly about how the thing actually drove, because it wasn't perfect, and I think the flaws are just as important to the story as the triumphs. Putting 475 lb-ft of torque through the front wheels of a car in 1966 was always going to be a fight against physics. Oldsmobile knew this going in. They partnered with Firestone to develop a completely bespoke tire specifically for this car, the TFD, standing for Tornado Front Drive, with stiffer sidewalls specifically engineered to handle the unique lateral loads of a wheel that is simultaneously being driven hard and steered. This wasn't a case of Oldsmobile just bolting on whatever tires were available. They went out and got a custom product developed because the demands of this drivetrain were genuinely unprecedented. But even purpose-built rubber couldn't fully solve the underlying physics. Car and Driver magazine, testing the car when it was new, recorded a 0 to 60 mph time of 8.6 seconds. Now, on paper, that's decent for a big luxury coupe of the era. But it's honestly well short of what 385 horsepower should be capable of delivering. Why the shortfall? 2 main reasons. First, the car had no limited slip differential, so under hard acceleration, if one front wheel found less grip than the other, power would simply be wasted spinning that wheel rather than being put down effectively. Second, and more fundamentally, roughly 60% of the car's total weight sat over the front axle. That's a huge amount of weight concentrated over the wheels doing both the steering and the driving, and it made clean, controlled launches a genuine challenge for even a skilled driver. The front brakes were also a real weak point in the original 1966 design. Oldsmobile used a drum brake setup at all 4 corners, and the front drums simply couldn't handle the heat generated by the car's heavy front weight bias combined with hard use. Brake fade under repeated hard stops was a documented, real-world problem for early Tornado owners. Oldsmobile recognized this themselves. They made front disc brakes available as an option starting with the 1967 model year, just 1 year after launch, which tells you how quickly this particular weakness became apparent to both engineers and customers. But here's the flip side, and it's a big one, where the car genuinely excelled was handling. This wasn't just a case of Oldsmobile getting lucky with an unconventional layout, they tuned the chassis with real intention. Front spring rates were 89% stiffer than a standard full-size Oldsmobile of the same era, and rear spring rates were 57% stiffer. The steering ratio was matched to the performance-tuned 442. Yes, the muscle car, rather than to a typical soft, isolated luxury car setup. And there was a hydraulic damper fitted to the tie rod, which was unique among American cars at the time, specifically engineered to keep torque steer from ever reaching the driver's hands through the steering wheel. The press noticed. British magazine Autocar, testing the car against the best that Europe and America both had to offer, called its road behavior clearly superior to any equivalent rear-drive car of the era, a genuinely remarkable statement for a British publication to make about an American luxury coupe in the 1960s, a period when British auto journalism was not exactly known for going easy on Detroit's products. And in rain and snow specifically, the Tornado's front-heavy weight distribution gave it real, measurable traction advantages that rear-drive cars simply couldn't match, because all that weight was sitting directly over the driven wheels rather than over the wheels doing nothing but steering. The press response when the Tornado launched was immediate and loud. Motor Trend named it their 1966 Car of the Year. Car Life gave it their Engineering Excellence Award, specifically recognizing the drivetrain work rather than just the styling. And in Europe, in the Continental Car of the Year competition, a contest that, Frankly, American cars almost never even placed in, let alone won. The Toronado placed third. That was something no American car had ever done before in that specific competition. First-year sales backed up the critical praise. The Toronado sold 40,963 units in its debut year, a genuinely strong number for a completely unconventional, expensive personal luxury coupe entering a market that had never seen anything like it. And then something happened that's almost a little tragic, if you think about it from Oldsmobile's perspective. Cadillac, GM's flagship prestige division, took the exact same UPP architecture that Oldsmobile's engineers had spent 7 years and roughly 1.5 million test miles developing, and dropped it into the 1967 Eldorado. And once buyers had the option to get the exact same front-wheel drive experience, the exact same drivetrain sophistication, but with a Cadillac badge on the hood instead of an Oldsmobile badge, a significant portion of them did exactly what you'd expect. They switched brands. Toronado sales fell nearly 50% the following year, down to just 22,062 units. Think about what that actually means. The Toronado had proven its own underlying concept so thoroughly, so convincingly, that GM's own internal prestige division felt confident enough to essentially cannibalize the car that had done all the pioneering work. Oldsmobile did the hard, risky, expensive engineering. Cadillac reaped a huge share of the reward. That's not a failure of the Toronado as a piece of engineering. If anything, it's the opposite. It's proof the concept worked so well that GM's most conservative, image-conscious division was willing to bet on it too. But it's a genuinely bittersweet outcome for the team that actually built it first. Stepping back from the sales figures for a second, what did this whole 7-year, 1.5 million test mile project actually prove? It proved that front-wheel drive could work with a genuinely large V8, not just a small economical engine like European manufacturers had been using. It proved that torque steer, that fundamental physical challenge of driving and steering through the same wheels, could be engineered out through careful, deliberate design choices rather than simply tolerated as an unavoidable side effect. And it proved that a front-driven American luxury car could handle as well as, or arguably better than, its conventional rear-drive competition, a claim that, before the Toronado, almost nobody in the American industry would have taken seriously. The UPP architecture itself didn't die with the first-generation Toronado. Cadillac used it in the Eldorado starting in 1967, as we just covered. And when GM downsized the E-body platform in 1979, the platform shared by the Toronado, Eldorado, and Buick Riviera, a re-engineered version of this same fundamental front-wheel drive architecture underpinned a whole new generation of front-drive luxury cars across Oldsmobile, Cadillac, and Buick simultaneously. The institutional knowledge that Beltz's team built during those 7 years of development, how to manage torque steer at scale, how to tune suspension geometry for a nose-heavy, front-driven chassis, how to engineer constant velocity joints and drivetrain components capable of handling serious horsepower through a steered wheel. All of that knowledge fed directly into GM's mass-market front-wheel drive cars throughout the 1980s, a decade when front-wheel drive went from being a radical experiment to being the default layout for the vast majority of American passenger cars. And beyond GM specifically, the Toronado showed the entire American industry something it desperately needed to see at the time. That front-wheel drive wasn't just some quirky solution for small European economy cars. It could be scaled up. It could handle real American power. That demonstration, more than any single sales figure from 1966 or 1967, is arguably the Toronado's most lasting contribution to automotive history. In 1966, the Toronado was an anomaly, a 385 horsepower front-wheel drive coupe sitting right in the middle of the muscle car era, built for buyers who wanted genuine technology and engineering sophistication as much as they wanted raw style and speed. It didn't reshape the American car market overnight. It didn't kill the muscle car. Muscle cars would keep dominating American roads and American car culture for years afterward. But it planted a seed. A seed that would take more than a decade to fully sprout, as fuel crises and changing regulations in the 1970s pushed the entire American industry toward front-wheel drive out of necessity rather than choice, at which point all that hard-won knowledge from the Toronado program suddenly became enormously valuable. The engineers who built this system spent 7 years and roughly 1.5 million test miles getting it right. Not because any regulation or fuel crisis was forcing their hand. None of that existed yet in the mid-1960s. They did it because they genuinely believed front-wheel drive was a better way to build a car, and they were willing to bet careers on proving it years before the rest of the industry had any real incentive to follow. That 2,294-piece chain running quietly inside the engine bay, that bizarre high-torque transfer system connecting a reversed automatic transmission to a massive V8, it was one of the very first serious, large-scale attempts to make that future actually happen in America. It was strange. It was arguably over-engineered for what it needed to accomplish. And if you look at the overwhelming majority of passenger cars and crossovers on the road today, nearly all of which are front-wheel drive or front-wheel drive-based all-wheel drive, you can trace a direct philosophical line right back to a chain-driven engine bay from 1966. Thanks for watching. If this deep dive into one of Detroit's most overlooked engineering stories hit the mark, drop a like and let me know in the comments. Would you have taken a 385-horsepower front-wheel drive Toronado over a rear-drive muscle car in 1966? Subscribe for more forgotten stories from American automotive history. I'll see you in the next one.